Hello and welcome back. Um, so in today's stream, I'll be continuing on from last week's session where I'd just put on the very first touches of implementing the Laurel programming language. So the so I'll basically be continuing from there this week. The two features that I'm hoping to implement are, first of all, um, finish off with this kind of introductory uh, feature for the language, which is the ability to call strings as if they're functions. And if you call a string in this way, then it runs the program with that name. Now, I'll still have to, in the say, full scale production ready version of this, I'll have to consider things like path handling, all this kind of stuff. But for the moment, it'll just be whatever is found on the path as normal. And if I get that working sufficiently, the second feature I'd like to work on is this basically looking at a shortcut kind of syntax for string literals that conform to a certain syntax. So yeah, I'm just going to get stuck in and we'll see how we go. So where I was last week was I just implemented the very basic our very first bits of this expression call support for strings. So down here we have a string. Oh yes, and I had this kind of shortcut for at the moment, function evaluation is split into two steps, basically to handle the case where the thing that's being called is a built-in function or a user-defined function. And now we're adding in strings. The reason for it being split up is because if it's not split up, or sorry, the reason for splitting it up is essentially when we kind of start the evaluation, we want to take out of the function, shall we say, mutex, all the values that we need. And this isn't so relevant here, but I'm using this either up notation that I'll be refactoring into kind of a three-piece tuple later on, or three-piece kind of disjoint union value. So yeah, what I have so far is basically you can call this program and provide arguments as if they're regular function arguments, I believe, or regular. So you provide them as if they were function arguments, but they're evaluated, as arguments to the program itself. So let's take a look at what that looks like. I think last time I was looking at ls maybe. So let's see. So if I do ls without any arguments, what do we get? Oh yes, and sorry. So so that was the kind of limitation last week. Is it just returns the whether the command was successful or not, and that's based on the exit code. So what I'll begin with is take a look at let's see, actually capturing more of the output stuff basically. So yeah, so the result is going to consist of so at the moment the result returned from a program invocation is going to be, it probably won't be a simple OK value here. It'll probably be an exit code, but OK is fine for the moment. What I'm going to add in addition to that is standard out and standard error. And those are just going to be captured and convert it to strings. Let's see here. So output standard error, and I'll need to do is it a string from UTF-8, I believe. Oops, keep doing that. And standard string. So I probably have to import that, but that is what I'm looking for, I believe, because the output normally comes in as a our standard error and standard out come in as vectors of bytes. So we'll put standard out here. And just for the moment, I'll put an unwrap here, which will error if there's an issue. I'll just put a no commit here to make sure that I resolve the errors properly before committing. And so, yeah, so that's not found in string at the moment. So I need to add that. And then consider borrowing that. Yeah, I can do that. And this should be S. And that'll be to string. Again, I'll be tidying all this up in a sec. It's just to take a look at the what actually what this kind of stuff looks like when it actually runs. So yeah, so here we have our expected output. Again, the rendering around here is a little unusual, so I might take a moment to tidy that up a bit. But in the meantime, we can see the output as expected. So the standard out is getting captured. It's outputting, all the values found here in the local directories, such as cargo lock, toml, license, makefile, readme, and so on. So what I'll do then is, let's see, make the rendering just a little nicer, or the printing. So at the moment, I'm just using the default debug out formatting for any values that aren't lists or objects. So I'm going to handle the others correctly. So where is value defined? Here. So we have, so we'll start off with null. That'll just be that. And bool b will be, yeah, if b, then it's true, otherwise it's false. Then we have int. In fact, for a lot of these, I don't need to give the I can probably still use format, but not use the debug format. So let's see. So I'll do that for that. Same for the integer. String can just be like that. List and object are fine. Built-in func. I'll just put in that built-in function. And finally, we have a regular function. And again, we don't have the actual names associated with those. Usually, yeah, that would probably be some handy to that would be something that would be useful to expose via reflection. But we don't need process result because we're going to encapsulate that using an object. But yeah, so that that should more or less clear up our rendered output. So let's take a look. And yeah, so that's redundant now. Cool. And so then our rendered output, now again, the string rendering, when there's when there are actual new lines in a string, they're not going to get properly indented using the current rendering mechanism. But that's something that can be addressed later on. But basically, we can see that standard out. Oh, in fact, what I could do is wrap strings in quote marks. So let's try that. Yeah, so that looks a bit nicer. So that is, yeah, what we'd expect. So the output of, so let's see, if we go to test, we have the output of the command false coming in as it's just that the exit code was not successful. Standard out and error are empty, but then in our ls example, excuse me, it did return true, but standard out is also populated with the contents of the current directory. And I believe I handled the args correctly last time. So then if I do, for example, ls depend.txt, then I'll get the correct standard out as well. So so arguments are handled as one might expect. Yeah, so that's pretty nice. So that's even already that's a relatively lightweight, in my opinion, approach to running commands in a scripting language. One potentially nicer thing would be to be able to remove those quotes around all the different string literals, and that's something that I hope to address again later on today. I'll just clean up the code that's there now, and then we'll take a look at making the rest a little nicer. So let's jump back to eval. So I'll jump to either up. And so the definition for where this stuff is running. So we have a couple of things. Yeah, the feature itself, that's that's more or less the implementation really. And it's just to be cleaned up really is the are the next steps. And now one thing to that I'll have to pay attention to here is the fact that so I'm using a string from UTF-8 here um, for more illustrative purposes. The way this language will work is it'll actually just be it will keep strings will be represented by essentially byte arrays under the hood, so they're not going to be proper UTF-8 strings always. So you'll be, for example, a stream might output or a program might output a stream that contains kind of non-UTF-8 code points. So for that reason, just to make things easier, we won't be kind of imposing that constraint that all strings in the language have to be UTF-8 compliant. But for the moment, the way the string value is stored at the moment is just using a Rust string. I will be relaxing that in time, but for the moment, I'll be just saying that they have to be UTF-8. So yeah, I'll just clean this up a bit, I suppose. So what yeah, first thing I'll do is I'll change OK to the exit code. And the first thing for that is to try and unwrap. Let's see. Yeah, so I'll do a match. So let exit code equals output status, and let's see, Rust command. I think it's just using output at the moment. And then status code. And we'll match on that. And that can be some code, or if it's none, then at the moment that's just that's going to be an error. Eventually, so this will be a source of kind of, this is somewhat platform specific. Eventually, if I decide to make this kind of more cross-platform, I could remove this limitation also. Maybe convert it to some kind of maybe either convert it to 0 or 1, 0 or 1 based on its Boolean value, or I could say that, you know, the abstraction itself will be based on Booleans rather than exit codes. But for the moment, I'm just going to handle it like this. So grab this and the error message here. And so in that case, so that'll now be an int. Then standard out will be something similar. and this will actually return an OK or an error. So in this case, I can just embed the error directly to say what went wrong. Oops. And I'll be doing something similar for standard error. Let's see how that looks. Use a comma to end the yep. Expected I64 found in I32. So where's that assumption coming from? Because integers at the moment. Okay, so I should be able to do, and again, I'll have to look it up. I always have to look up casting in different languages. Although, is it the as keyword? But basically, I'm getting the exit code as an I32, and the language itself, the Laurel language, is expecting an I64. So yeah, that's cleaned the code up a nice bit. So next, what I would like to do is, let's see. Yeah, so I need to deal with the ethers, because either up is a little tongue in cheek. I'll replace that with a more kind of appropriate or kind of fit for purpose enum. I'll probably also extract the logic for calls into its own function as well at some point. So this essentially, yeah, it splits the, if we call this, again, could use the terminology from SICP, but this is basically separating the pre-evaluated function call and its arguments from the actual evaluation of the function calls. So maybe pre-eval function here. And this will be a pre-eval call rather than a function, because again, because this new concept is introducing kind of calling of strings essentially, which aren't functions. So I'll update the terminology there. So let's see. I'll now put these like this. So we'll have a pre-eval call. Is there a better name for that? Prepared call, packaged call, bound call. So where the arguments and a call binding maybe. So, and that would be built-in func. And we'll have the function itself. That'll use the same type, I believe, as the actual value, the value type. And then the args will be vals. What are they defined as? So those are going to be values as well, or valref with sources. So it's going to be a vector of valref with source. I wonder will that be, that'll probably be in common to all of those. So maybe I'll abstract that later, but then might not even be necessary anyway. So let's see, built-in func. So we have f is going to be a clone of f, and args is going to be vals. So there, that tidies, makes things a little clearer in that area anyway already. So then we have a regular function, and we'll have new bindings, which will be a vector of expressions and valref with sources, and that is the parameter list essentially paired with the expressions that, because we're supporting decomposition or destructuring in the parameter list, so we actually keep the source expression with the value, so that then when these bindings are evaluated, we can actually, because it's not a one-to-one mapping from names to values, the left-hand sides of these bindings could actually be structured values. So we need to keep the expression so that they can be evaluated. So then we'll have closure. Where does that come from? That comes from the function itself. And so that's a scope stack and statements. Essentially what we're doing is kind of cloning the value, because it's it exists in the it likely exists in some scope, and we can't keep a reference to that because it's within mutex. So if we want to be able to call it recursively, for example, we need to make a copy so that it can be called recursively. Eventually, that's, I assume I'd need to optimize that in some way, because it will be a bit painful for recursive functions or for functions in general to always have to be copied. And maybe an optimization should be to only copy it if recursion is detected, for example. But again, that's an optimization that can come later. This is functional as is. So let's see, the final one then is if I call it a command. And in this case, so I've kind of put the evaluation in the setup in the call binding part. But if I were to kind of split this up properly and according to how the other ones are set up, then I would say that the program in this case is a string, and then I could get the args, which will be a vector of strings. And that should be it for the type definition. So let's see, call binding func, and this will be do I call it new bindings down there? I do. Maybe I'll just call it bindings. Yeah, and so that's that done. And then finally, we'll have a call binding with a command. And this is going to consist of the program itself, which will be prog captured from up here, and args. And that'll just be that as well. So I can actually put those all on the one line. And this is the part that'll be moved down below. So then, yeah, these all have to be updated. So we've call binding built-in func, whoops. And we have f and args. And so vals will just be replaced with args there. We have call binding func here. We'll have bindings, closures, closure and statements. Whoops. So new bindings will just be replaced with bindings. And then finally, we'll have call binding command will be, let's see, oh yeah, program and args. And so the actual evaluation will be moved down here. And done like that. Is there a shortcut for doing all that at once, for adding the program and its args? At the very least, there's probably a builder pattern. Yeah, there we go. Creates temporary. Yeah, that I had a feeling that was the case, even though here they're using the then they're using it all in the one statement. So yeah, maybe I can't do that the same way that they're proposing it. Creates a temporary, it's freed, yeah, and the output then is. So we'll do it like that. Yeah, and now we have the exact same thing, but hopefully, yeah, I would say looking at a good deal tidier. So we have, let's see, that's all been refactored, either has been removed, and I've updated the rendering semantics. So maybe I'll start with that um, is adding, is updating the rendering. So it's not really refactoring, it's, well, it somewhat is, but make value rendering more consistent. And then the rest of it. So we've got command and string, yeah, they're in the right place. Yeah, and so I'll commit that, and that is allow strings to be called as commands. Cool, and so that's the first Laurel kind of innovation or feature, or yeah, whatever we like to call it. So nice one. So the next again, if I could call it I suppose novelty for the language is allowing a more lightweight syntax for string definition, because again, so in this language, because the emphasis is going to be on calling programs again, so this language, the intention is to be an alternative to Bash and give more kind of consistent semantics and control flow, but keep the ergonomics of the Bash language itself, notably around calling functions, passing arguments to functions, and things like that. Bash is very lightweight for that. I mean, to call a function with arguments, you just write or to call a program with arguments, you just, write them. You don't have to pass them as arguments to another function, which then calls the program on your behalf. You just type the program that you want to call, and using white space separate the parameters. This language is going to be a little more verbose than that, because it'll take the approach that we use parentheses and commas for delineating argument lists, but it's still going to want to try and match Bash in terms of having this kind of lightweight feel where, for example, strings don't have to be quoted all the time. So that there is a challenge there in the sense of it's not as straightforward as, so if we take a look at how we're going to actually implement this, it's not going to be as straightforward as, so if, can I have different string literal approaches? I probably can. So it's not going to be as simple as remove quotes from string. So you can just type any anything and it'll be a string, because then your whole program, if you have nothing to delimit strings, then where do they start and end? So instead of having delimiters, it's going to again use the same approach as bash, where we say, okay, if it matches these specific characters, which essentially are going to be the identifier characters. So now any valid identifier is actually a string rather than an identifier. But naturally, the question arises: what then denotes an identifier? How can we have variables, for example? And it's unfortunate, but I'm going to take the same approach as PHP and Bash in this regard and say that variables and kind of names in scope are going to be prefixed with dollars, dollar symbols, and that's okay. It's something that I didn't like for years. I never really understood why PHP and Bash use dollar prefixes to denote variables. I think Bash has actually a very valid reason, which is otherwise, you couldn't distinguish string values or string literals from variables. So in Bash's case, I think it's justified. I think it's and again only justified because the emphasis in Bash is on calling functions and passing parameters and having strings as a kind of a base type. It's kind of every most things in a Bash script are strings, so it makes sense that the syntax for defining strings is as lightweight as possible. I'm not sure that the same could be said of PHP. My guess is, I'm not a programming language historian, but my guess after looking into this stuff a bit would be that PHP just kind of copied it from Bash more or less. Does Perl? Can't remember if Perl uses that syntax, but I would imagine that the idea of using dollar prefixes came from Bash, because Bash is, would be, well, not necessarily Bash. Again, when I say Bash, I'm more referring to shell rather than the born again shell. I just refer to it as Bash in general. But I would imagine that this idea originated in shell programming languages, for this valid reason, and possibly just got inherited by other languages just out of stylistic preference, more than anything would be my guess, basically. But yeah, so that means that when we come over here, identifiers are now going to have to be prefixed with dollars. So let's yeah, because if we just try to compile this without doing that, making that distinction, yeah, we're getting this massive conflict issue. Whereas if we now, I haven't tested this out, so this could also kind of raise a conflict issue, but hopefully it won't. Let's see. Yeah, so we made it past the parser code gen part, so it's looking like that's all right. And yes, that's exactly what we'd expect in this case now, because the language itself has been updated so that all of these, what were identifiers in the language, are now all string literals. So result now has to be prefixed like this. Strings can and will still be delimited by quotes, so this should work. Program arguments must be strings. Not sure where that's coming. Yes, yes, I know where that's coming from. I'll address that in a moment. But if we change that to, or we'll just comment that out for the moment. But where we are now is, oh, interesting. No, this isn't what I expected in this case. So let's see what's going wrong here. It's saying program arguments must be strings, but it's because print itself as well is currently a technically a variable or a binding in the language. So it's interpreting this as a string, and so so that's happening. So we need to put a dollar before print as well. Again, I'll be looking at how do we make these more ergonomic in general. So for this, I'll want to strip or trim the prefix. Can I do this maybe instead? Okay, no, and that's all right though. What I'll do is I'll just, let's see, Rust string trim prefix. Trim start. No, not trim. So in that case, strip prefix. And again, I'll do an unwrap here for the moment. And that will be, I'll strip the dollar. Realistically, the unwrap should be all right there because again, I think I mentioned this before. This is a kind of this is something that the compiler itself with types can't verify that, the dollar will always be there, but we as programmers have that knowledge that if we get this far in the program, this will already have been verified at runtime. So, this unwrap should always be successful, in which case, panicking is almost a valid approach here. I still prefer to handle errors, even if a panic is somewhat justified. I still prefer to handle them as kind of regular errors where possible, but expected that, so I just need to put an ampersand at the start there, do I? At the very least, I can replace this with an expect. I probably won't. I'll probably leave it as a panic, but in fact, I'm doing an unwrap down here as well. So maybe I'll just leave it as that actually. Try using a conversion method. So it's okay. Yes. So and so what was it given before? Oh, I misunderstood the message. So what I'll do is, whoops. Can I strip prefix directly on that. I'll check that out. Okay, that's all right. Nice one. So yes, so now at the cost of now polluting the kind of namespace for variables, I now get the benefit of being able to just call all these things without can only call functions. Well, first of all, that shouldn't be true anymore. So where is that coming from? So match value v. And just for the moment, I'll say what it got. Got v. Got a Boolean. Okay. Oh, interesting. Yeah, that's interesting because false then is a an actual keyword in the language. So that'll probably have to stay as is, or otherwise I can, the decision there will be, okay, if you actually want to call the program false, you have to quote it, or else if you want to have the Boolean literal, you have to dollar it. I'll make a decision on that later, but I will note that down. Because that is a bit of an oversight, but for something like ls, like we had down here, that should be all right. Okay, finally, and then we can have this. Oops, I didn't save the right file. Yeah, so that's yeah, there's the big innovation that I was hoping to implement with this language. Didn't really take much in the end. I suppose I'd been planning it for a while, but this is the core anyway of how do we keep this whole thing lean. So and so for example, if I wanted to say, okay, I want to LSL scripts and tests and docs. Again, I don't have to quote any of these because of the decision I've made with regards to variables and identifiers. So I can just do them, use them as is. So that's yeah, I'm pretty happy with that. I like that. So let's see what actually changed there. So I'll remove the debugging bits. And yeah, that was basically it. I just updated the grammar itself. and kind of made a, in fact, what I'll do is reset head there, and I'll actually add that to the previous commit, because it's a correction for that, and then the rest I will, because I haven't pushed this yet, so I can rewrite history a little, and yeah, so that's the more kind of lightweight approach to calling functions anyway. So I could, for example, do let's see. Again, I'll print it and I'll do a get status. And in fact, and no such file or directory. Okay, so Git actually isn't installed in this environment, in the inner container. I probably don't have many commands in there at all. So I'm kind of surprised that Git isn't in there. Let me think, is there anything else interesting that I could call from in there? I suppose I could call my make file maybe. Well, I'll just print the string make. I actually need to call it now. Yeah, and that's all that's done is run the checks. So it's run my linters, and it's saying that all my lines are overflowing. And then I get standard error as well. So if I did make, and let's see what targets I have here. So if I went into my make file and I went check, oops, check lint, and it'll just run that one target or that one recipe. Oops, what's happened there? Oh, it's just taking a long time. Oh, is it taking a long time? It didn't run checklint before. It was running check style. Yeah, so it just took ages to run checklint is the issue there. So I'll run check style instead, and that should be a little quicker. Yeah. So that's that. So light way of passing arguments and running programs. Since I've finished those up so quickly, I can actually move on to the third novelty of this language that I was hoping to introduce, which is kind of support for subcommands. Now, for this, I think Git is is actually a good candidate for kind of showing it off. So what I'll do is I'll actually recreate the build environment, or yeah, I'll add Git to the build environment. For the moment, I'll add it as part of a new section or a new layer in the Docker file. Ideally, I would put it in the one where it's getting set up, but you know, that's all right. So let's see. Oh yeah. So first I'll have to exit that. I'll have to rebuild my build environment and have it install Git. So I can go git status. Yeah, and That's as expected. So now git my build environment contains git, and it was dreamy growth and diak. Was the NORPL. Was the name before, so this time I will have confident Spence as the build environment. And so then when I run the command, okay, yeah, so I have git status is now running. And if I did a more complicated git command, let me think. Maybe see what's git check current or get branch name for commit. And so we'll say git branch A contains commit. So we'll say git branch A has to be quoted because it's hyphens, so at the moment it needs to be quoted anyway. And then contains, and same for contains. So I have ideas to make these more ergonomic in future as well, but you know, that's just the way it is at the moment. So maybe if I do a git log, grab one of these commits, copy that, put it in there, and let's see what we have. And if I did git status as well, just as another command. Okay, so yeah, those are all as expected. So then the next next piece that I'd like to add in here is, now it's not the nicest thing in the sense of it's essentially adding an additional way of doing the same thing, which I typically like. I like the Python idiom of, you know, there's only one quote unquote right way of doing things. And it's nice when the language even enforces that. So, you know, you're kind of forced by the language to do things in the right way. But the other way is idioms, and the approach with this, I suppose I'll introduce the feature first, and then I'll say when it should and shouldn't be used. So let me see here. So this will be the property syntax. So yeah, so if there's a property access on a string, then what that's going to be is that won't actually be a property access anymore. Instead, it'll actually be adding arguments to a command. And in fact, that's going to require us to add in a new value type. So even though I've added the idea that we can call strings as commands, I haven't actually introduced a new command type, or a new, like, commands aren't a first class value type in the language just yet. So let's go ahead and rectify that. So they're going to be encapsulated or you know, represented using just kind of the Rust, it could be called primitive for commands, which is just command. I believe that's part of the standard library. Yeah, it's because I didn't have to import a crate for it. And so what's going to happen then is when I perform a property access on a on a string, then, and where's name coming from? Okay, so name is there. So when I perform a property access on a string, it's not actually accessing anything from the string itself. It's actually basically appending that new string onto as an argument onto a new command, essentially. So let's see. So this will then return Can I just return it at the end? Yeah, I think I can. I could potentially remove that return as well. First of all, yeah, let's see what happens if I do this as just as a little cleanup. Is that because not all code paths are returning something? Oh no, it's because I'm matching, or I was swallowing the value there as well, I think. Hi, an unavailable user. 5. Good to see you. Yeah, I'm doing well. Was it finally getting into kind of some of the meaty features of the Laurel programming language that I was hoping to get to, and also got through kind of the first few features fairly quickly. So yeah, doing pretty well. How are you? So let's see. Okay, so values have to be clonable, but command isn't clonable. So that's one potential issue. We'll take a look at that maybe a bit later instead. Oh yes, so removing another semicolon is the issue here. Okay, so that works again. And so in here, what I'm going to do is I'm going to return a command. And yeah, so it looks like so in this case, basically the program will be S. So because command isn't clonable, I'll probably just kind of save myself the hassle and just, you know, kind of take the pieces I need and store them in kind of a base representation myself. And in that way, you know, I can work around the fact that command isn't clonable, and it probably makes a little more sense because I suppose I'm closer to the data that way. Unavailable user 5 says I'm good, but I can't find resources on making a programming language in C. Reddit had some useful responses. Yeah, and so are you saying that you're using C as the kind of implementation language, is it? So I think, do they call it the source language, or the language that you're actually implementing the programming language in? Yeah, C would be it would be a tricky one to write in, but I feel like there would be a number of resources on that. Not that I know of them, and the main resources I'd be familiar with would be yeah, in fact I can't even remember what resources I used for learning a lot of this stuff. The Dragon book is kind of one of the definitive ones though, and they probably use Yak and Bison, which would be C based. I would have thought. Yeah. Um, in fact, the original compiler for Go and Python, again, it's probably tough to to learn compiler implementation from such kind of advanced projects. But even though the Go programming language compiler, at least the parts that I've seen of it, are kind of penetrable enough. So anyway, sorry, I'm kind of rambling a bit, but yeah, I think that seems to be a recurring theme from people who've been commenting on this stream, is that there aren't really too many resources on writing programming languages in general, never mind C. So yeah, maybe you know maybe that's a good opportunity for some to step in and do do maybe a modern approach to it, because like there are a few resources in it. I'm not sure if I've seen too many videos on it. That could be a nice one, or a lecture series. Maybe there's an MIT course about it or something. I'm not sure, but yeah, uh, it does seem to be a thing that there are few enough resources for getting started with compilers, or programming languages in general, I think. Um, so args, we have vector of string. Yeah, and I think so. This will be a vector of string for now. Uh, everything that, yeah, I think. Hmm, oh, no problem. So so eventually, everything that goes into the args of the program will be a string at some point. Whether we want to keep it as a val ref with source until that point and then evaluate it at the last moment, there probably isn't a need. Um, but for the moment, this should be fine for our usages. So to start off, this will be a, a vector with that. So let me think. So that's or no, not so S won't go there. It'll actually be name will go there, and so name will be the first. Now I should probably change name at this point, because, and even the name prop probably won't be so those things will need to be renamed to account for the fact that you know the property operator can be used with strings, but so expected a string, found that. So can I just clone that? And same there. So now next thing to do is, because I have a new value type, I'll probably have a bunch of places where I need to, yeah, where I now have non-exhaustive patterns. So 128, no, so that's in main. Where's the other one? Both are in main. Oh, it's because of the new rendering logic I put in there. So yeah, for the moment, I'll probably just do use debug formatting. Um, um, hmm. what's my best bet here? And maybe I'll just actually do it correctly then. So let's see. Well, I'll do it partly correctly. So program will go there and args will go there. And maybe, yeah, I'll surround the program with quotes, because even though it'll usually be, I'd expect it'll usually be a proper identifier. That's not guaranteed. So so main 131, and similar down here. Okay, so we're compiling again at least. And so, yeah, so that means hopefully if I then, well, first of all, I haven't actually allowed, so one thing that this has changed is I can now create a command by chaining like this. So if I print this, I'll get a, it'll render git with the argument status. Unrecognized token though. Okay, interesting. This isn't. So status is an unrecognized token. Huh, interesting. And this is kind of partly the reason I wanted to start off with a kind of a core programming language base before I got kind of stuck into syntax and features of this thing, because I did imagine running into these kind of parser issues resulting from trying to use kind of basically identifiers as strings in this way. So what did it expect in this case? Okay, so it expected at the moment a property can only be used with an identifier. Yeah, with an identifier. However, in this case, actually, this is a good opportunity to be able to make a distinction between the two. So there's going to be, the possibility of a property access, and there's going to be the possibility of to distinguish the operators so that it'll be if we call it the argument operator or something like that. So use different expression value. So for the moment though, I'll just keep it more or less the same, just to get the sample running. And do I have, okay, yeah, so there was an extra line up there, I forgot about that. I'll put that down there for the moment, but basically what I'm focused on here is this will now create a new command because I've strung the two strings together. Yeah, and so we have a git program which will take status as an argument. So basically, these two will now be equivalent essentially. Well, not yet, but these two will be equivalent. So this would be calling a command that's defined based on the chaining of a program followed by any number of string arguments. And in fact, Docker might be, although I don't have Docker exposed here, but Docker will be a good example of chaining as well, because Docker can have a lot of subcommands. So for example, I might have Docker volume ls, for example. And again, that would be equivalent to Docker volume ls, which would be equivalent to Docker volume ls. And I was mentioning before, yeah, that's the not nice thing about this approach, in my opinion, is the fact that this introduces different ways of doing the same thing. The answer to that, in my opinion, especially in this kind of a case, is for the language to have idioms. So it can't kind of enforce one approach over the other really at the language level, because it doesn't I suppose have the knowledge about the commands that are being run to be able to say, hey, use this approach instead of that one. But this will be a kind of a developer level idiom where the approach will basically say, okay, so we're always going to be starting off with the program name, and so you can use this kind of dotted chain notation for subcommands only. So the idiom will be, this syntax will be for subcommands, and then kind of positional arguments go inside here. So basically, in that regard, even though both of these are also possible, they won't be they'll be non-idiomatic. So that's one thing. Now, I don't. Well, there's a couple of things wrong with that, so I'll put that down there for the time being as well. Most of all, I think, yeah, there's a couple of things going on, so I'll go through them one at a time. So first thing to note is that, so I'll try it out with git status. So a second ago, I was able to just run it like that, and we were able to print the fact that it's actually a command. However, if I actually call that, we don't actually have call semantics on commands yet, because that's a new concept. So that needs to be introduced now as well. So so this will be a new call binding as well. And we can actually reuse the string one, because the string is basically, it's somewhat of a shorthand for this anyway. But we'll have a program, and we'll have args. And args are already strings. So in this case, we can actually just do this, I think. And that will allow us to, oh yeah, so I'll still need to clone those. Okay, and now, so that is, so we have these two ways of basically calling subcommands. So both of these output the same thing, but this would be the idiomatic approach, because git status is its own. Well, I'll just double check that. Whoops. Yeah, git status is a subcommand, I believe. So in that case, this would be this will be the syntax that will be used. And I think this is nice. It's again something I've been thinking about for a while, but it's still relatively lightweight, but gives a kind of consistent semantic. It, to me, if you're doing something like git status or no, I'll go into that after the next thing I implement, because I want to. So the next issue with this is that I haven't actually allowed for chaining. So what? So Git has some so Git remote in particular has a lot of subcommands you can use. So you could have Git remote list Git remote get URL maybe. Well, no, that's got hyphens in it, so maybe not. Git remote rename. Yeah, so in this case, we might have remote rename, and we'll have A and B. But this doesn't work yet, because even though I have allowed chaining on strings, when I chain the first string to the initial string, that that creates a command. So then this third one is not operating on a string anymore. This is a command. So again, the error itself has to be updated too, but I need to add extra handling so that what's called property access at the moment, we should also be able to do that with commands. And so what'll be happening here is we'll have a command, and the only thing we're doing here, again, not the most efficient, but not the most efficient, but it'll be, again, functional. So args is equal to args push that. What's the best way to append a value to a vector in Rust? And so there's push anyway. It mutates the thing in place, so maybe that's probably yeah, that's probably a fine approach for now, since I need to clone the thing anyway. So let's see, yeah, I'll just call it args prime. So args clone, it'll be mutable. Args push, and args prime. So that should then allow us to call to do this chaining. And so now we have this git remote rename all new. So this should be the error we're getting up here. The error we're actually getting is git remote rename old new. So it's acting as if we didn't pass any arguments. So let's take a look at what's going wrong there. So when we do the call binding, this could be due to the order in which these are evaluated. The intention is that these are bound kind of to be left associative. I wonder, could that be the issue here? No, still getting the same. So what I'll do is I'll actually put the value in there. And try that. I'll print CMD as well. Yeah, so it's remote and rename. Oh, because I'm not actually appending the extra arguments. So when it's a string, all the arguments come in the arguments list. And when it's a command, I'm using the arguments that have been built up in the chain, but I'm not actually counting the ones that are in the arguments list there. So that's only a small thing. So what I'll do is, again, don't recommend my development naming approach to anyone else. It's fine, it's functional, but again, this is not a production ready naming. So so first of all, we'll do args. Probably have to do a clone of args, and then maybe actually is it extend? From raw parts. I know there's concat, but is that my best approach? Maybe actually. And can that be done on a slice or an array? So it seems it's all right on an array. So let's try that. So we've args and we've oh, I forgot that no, I think that's all right. So vowels, yes, sorry. So vowels are again, even my own naming approaches are tripping me up at this point. So let's try that. Expected vector of strings found just a vec. Oh, mutex with source. So maybe actually I'll have to do this as well. Okay, so that's no such remote A. Still not the same result as I'm getting down there. Now that could be because of different versions. 274, very old, and must update it at some point. So actually, git version 2.30. Yeah, so maybe that's the reason for it. Could not rename config section. Git remote rename. And if I just removed the second parameter from that. Yeah, so it complains if I don't provide both parameters, so it's probably the expected approach here, or the expected output. So, I never changed that to exit code. Yeah, so exit code too. So yeah, so going back then, the nice thing about this approach again is, yeah, I would say the kind of consistency. It looks like you know, kind of regular method access, and maybe that could be yeah, I'd call it subcommands in the parser, or in the parser properties. What I would say, oh, I lost my train of thought about what I was talking about earlier, of course. But yeah, so I suppose one thing to say about them is, even though they're structured in this way, or yeah, so I suppose it kind of one of the nice things that I like about it anyway is that even just like this, I feel this kind of illustrates the intention better than something like this, where we're treating the subcommands almost as almost it's like method access almost. So the parameters look as if they're parameters to the subcommand rather than um, all of the arguments to the command, even though these are arguments to this subcommand of this command, they all just look like arguments to the overall command. So I think being able to add in this chaining, while it does mean that there's more than one way of doing the same thing, does add some extra clarity in my opinion. So let's see. There was git branch down here. I think this was just kind of more of the same thing, really. I think the git remote kind of gave the clearest kind of illustration. But that's more or less that feature then. So with that said, the next, so I suppose, yeah, I'll just work on getting that committed. So there are a couple of things. So first of all, I'll commit that change on the exit code. I won't commit that just yet. Nope. Yes, exit code. Rename subcommand and in output object to exit code. And then the next thing I want to do is, rename that. So if it's string literal in this case, we know that application. Oh yeah. So in this case, we know that it's not a property access. It's instead a subcommand, even though it uses the same operator. Even though we could use something like that. Who knows? But yeah, other than that, the two are more or less the same thing. Couldn't be grouped under index. No, safe to just separate the two for now anyway, and I can merge them again later if I decide that it's simpler. But there's prop, and now there's subcommand. Can only, so this won't be, like I mentioned before, so this won't be an access anymore. So this will be adding subcommands. And that is that all right? So subcommand is now not covered in 295. That's a binding, so can't bind to a subcommand because it's not an area of memory. It's a literal. So that's that then. So then we've subcommand there and there. We refactored that a bit. And so we will update the test a little bit. So what subcommands are there in this remove a rx. So where is my Docker file? So I'll leave this here just for the sake of the testing, but I do want to move that in with the rest of the installs. I just don't want to break the cache and have to reinstall all this stuff. So move or add this to the apt-get install section above. And this is, even stuff like this is partly an inspiration for, like things like Docker files are partly an inspiration for this language, because like this is somewhat of a, shall we say, this approach to laying out Docker files is an approach that I've just kind of converged on over the years. But it's, I wouldn't say it's the nicest. It's like technically it's all on one line. The spaces kind of matter and things like that. Whereas if I were to refactor some of this, say in the Laurel language, let's see what some of this would look like. So now, granted, I don't have support for hyphens yet, so it would probably fall down there. But we'd have something like update apt-get. Oh yeah, and it would need brackets there, but then we could get rid of these again. If Docker files actually add support for this stuff. Would be assume yes for the moment. Make Python 3, Python pip, and wget. And it is a little messy because of the extra handling around. For example, what am I trying to say here? Of handling around the hyphens at the moment, but at least we're getting rid of, the start and end are kind of delimited by your typical parentheses or brackets. To me, things just look that little bit more uniform. And then if we apply, well, it'd be kind of more or less the same here. Again, the support, the lack of support for hyphens at the moment probably reduces the effectiveness somewhat, but that is something that I will hope to address in time. So we have that. So git commit, and that is allow chaining subcommands or add support for chaining subcommands, and I'll push that. Okay, so then what is next then? So I do have 10 minutes left. Let's see, is there anything else I can squeeze in, because there are a lot of things that I'm wanting to add to this language. Didn't really think I'd get through as much that I get through as much today as I did, and maybe that's a good opportunity to kind of quit while I'm ahead. But I'm just going to take a quick look at what else, what other ideas are available to me to try out at the moment. Yeah, realistically, it's only going to get trickier from here. The ideas I have in terms of, error handling, um, importing code, um, things like that, and proper handling of strings and things like that. Like, what's there at the moment is more just to get things working rather than the this the kind of more production ready solution. So maybe that is a good opportunity to leave things as they are. Again, I'm just gonna flick through some notes, see if there's anything else. Like one thing that could be possible to play around with is looking at how hyphens can be handled. Um, like the big difficulty with hyphens is that they can be used. So at the moment, you know, even though I allow uh, identifiers to be uh, what am I trying to say here? You know, identifiers have to be prefixed with dollars and things like that. It is still possible to use regular notation with them. So for example, like include them as parts of proper expressions. Um, and yeah, I have 5 down here. The difficulty with hyphen is that if I decided to say that a hyphen is part of a regular identifier, then that could cause issues with kind of minuses, I believe. In fact, it would probably cause a conflict, I would assume. Well, let me just test the theory. And if I have a hyphen in there. So a string literal can start with a hyphen. And again, mentioned it before, but this is part of the reason for starting with a core language and refining the language based on a core set of existing features. Oh, that actually worked. Okay, so that could be interesting. Oh, but wait, didn't that say so a second ago that was yeah, there's the problem though, isn't it? Is that did I get an unrecognized token there or something? Wait, no, what was the issue? Um, invalid token location 7. Yeah, I'm not quite sure what exactly is going wrong there. Actually, I wouldn't have expected the parser to even support it or to even yeah, be able to be generated without having a conflict. But even if it is, it looks like it's causing some other issue that I'm not even sure what the kind of cause of it is. Yeah, so without the hyphens in the string literals, that that runs fine without the hyphens in the string literals, but allowing hyphens in the string literals seems to cause very funny stuff. Unrecognized token at position. Is hyphen there being interpreted as a range or something? Maybe that's the issue. Rust regex hyphen. In character class. Yeah, so I do have to. Oh, still though, if that's allowed, that is a bit of a game changer because I was when I was kind of playing with ideas for this language, it was under the assumption that hyphens wouldn't be allowed in string literal slash identifier things. So that something like that is potentially fine. Okay, that's a very nice development. It'll help just keep things a lot more uniform as well. So I could also do something like, apt-get install help. Let's try that. Okay, yeah, so that just works as desired, not necessarily as expected, but that that's actually very nice. Now the one case that still won't be covered is the case of, for example, if I had a program in the local directory such as ABC, or in fact, do I have a program in the local directory? Or if I said something like, well, let's see. Well, there are a couple of things that this won't match on. So, for example, I couldn't do target debug norpal and then help. I would have to escape all that. And similarly, if I had, for example, a bash script, I would have to go script.sh, or similarly for Python 3, I'd have to go script.py and call it like that. But having said that, I didn't actually print the output from that. I just say, yeah, no such file or directory. But I wouldn't be able to unescape that because that'd be treat it as two distinct strings. That that itself is probably fine. Um, Not too big of an issue in my, I would say, and probably worth the consistency. But just the fact that identifiers can contain hyphens, that's that is nice. That was unexpected. So I'm going to keep that in there. Um, so these aren't necessarily string literals anymore. They're kind of their own thing. They're nearly like uh, kind of string identifiers. Um, but they should be allowed where more or less uh, anywhere that string literals are. So their position in the parser is probably okay. Um, I'll just when referring to them, I'll change the terminology. So yeah, just one line change. But yeah, with that all said and done, that's a nice bit not done today now. Um, I have to say, pretty pleased with that, especially since these are all kind of new ideas that I've been toying around with in my head for a while. It's nice that they got implemented so quickly. So yeah. Anyway, I'm going to leave it there for the day. Thanks very much as usual, to everyone watching, and yeah, I'll be here again next week, same time. So thanks very much, and talk to you then.